So yesterday we looked at permutations, right? Permutations, how many ways you can arrange something or how many possible outcomes you could have. Okay? A lot of times that involves factorials, but not always. Alright, not always. Okay, so now we got to look at the difference between permutations and combinations. Alright, so a permutation is what we did yesterday. Permutation. And the main thing here is that order matters. The main difference here is that order matters. In other words, a different order counts as another permutation. Okay? Different order counts. Okay? So a combination, the order doesn't matter. Okay, so a different order of the same element, just a different order, does not count. So if we go back to our first example from yesterday, which is A, B, and C. We have three letters, A, B, and C. Okay? We said we had 6 permutations of that. Right? A, B, C has 6 permutations, right? We can put that in order 6 different ways. How many combinations does it have? If you're not going to count a different order, then this only has one combination. An A, 1A, 1B, and 1C. If the order doesn't matter, it only has one combination. Okay, because if you say BAC, that's a different permutation, but it's still the same combination. Okay, so let me just put that down. BAC is a different permutation. Can I just shorten that? But same combination. Different perm, but same column. Not sure how that would work out, but okay. Which one is going to always be more? It's kind of obvious now, but which one is always going to be a higher number? Permutation is always going to be a higher number than a combination, because a permutation you're counting each time, like you put something in a different order, and combination you're not counting those. Okay. So permutation is always a higher number. Let me give you the formula for the combination, even though you probably never use it. But NCR, that's N objects taken R at a time, just like the NPR from yesterday. Okay, N objects taken R at a time. But if the order doesn't matter, then the formula is almost the same. N factorial over just a little bit different. R factorial over N minus R factorial. So this part of it, the N minus R factorial, is the same, but there's this extra thing in the denominator, this extra R factorial in the denominator, which is always going to make the combination smaller than a permutation. Okay. Okay. So let's look at. I want to look at an example of one problem, and we'll look at it 2 different ways. One that would take a permutation, one that would take a combination. Okay. So let's pretend there's 20 people in this class. And we need to, how many ways are there that we could pick 3 officers? Well, we'll say three captains. Okay, how many ways could we pick 3 captains? That's if everybody was eligible to be a captain. Okay. Okay. So, does the order of the captains matter?
No.
No. So this is a combination. And so we have 20 to pick from. So this is a 20C, and we're picking 3 of them. Okay, so it's a 20C3. And you can put that in the calculator and do that. Now, if we said how many ways to pick a president, VP, and secretary. How many ways to pick a president, vice president, and secretary? Now, so you know, if Mary Kate is the president and Jasmine is the vice president, that's different than if Jasmine is the president and Mary Kate is the vice president. Okay, those are different. So we got to count them both. So this is now a permutation because these matter. The order matters. Each of these positions matters. Okay, so that would be 20P3, and that would come out higher than 20C3 for sure. Okay, you guys understand the difference there? So I mean, this one's kind of obvious, but sometimes you really kind of have to think about it here. If the order matters. Okay. Let's say we have 51 contestants in the Miss America pageant.
Wait a second. Hold on. So like, there's like more than
Puerto Rico gets a contestant, I think.
Okay.
What? That's 51, right? I don't think so. No. I think it's Puerto Rico that gets it. Okay. I don't know. This is out of the math though. How many ways to narrow this down to 10 finalists? Okay, so we got to get 10 finalists out of these 51 contestants. Does the order of the finalists matter? Not right now. Not on the round to get down just to 2 to 10 finalists. Then they're going to compete later to see who's the champ or whatever, right? Okay, but right now to get the 10 finalists, the order doesn't matter. So that's going to be a 51C10. Okay, you do that in the calculator. Yeah, that's going to be a big one. Okay, now, you're not always going to use a CRP for these problems. A lot of times you are. If you're taking a certain number from a certain number of objects, and you're choosing a certain number of them, that's going to be a permutation or combination. You've got to figure out if order matters. But some of these problems are a little bit different. Like, let me give you an example here. You can always go back to lining up your spaces like we started off here. Okay? So, if I roll 4 different colored dice, differently, I guess, differently colored, I don't know. How many possible outcomes are there? Well, the color matters on this. Well, what does that mean about this problem? If I get a red 5 and a blue 2, that's different than a blue 5 and a red 2. Okay, so it'll be a different. There's more possibilities on this. Okay, but it's not really a permutation because there's not really factorials involved. Okay, so really what we just want to do here is set up our spaces. Okay, we're going to have 4 dice. All right, and how many possible? There's 6, right? Well, this is yeah. I guess there's different kinds of dice, but we're saying regular dice. There's 6 sides, right? For all of you Dungeons and Dragons fans, there's more kinds. We're talking about 6. I guess there's not too many. All right. So yeah. So the next one's going to be 6. Yeah. So you would just, and what do we do with these? You multiply them together, okay? So that, or you could say 6 to the 4th. You could say that 1296. Okay. How many ways are there to? Here's another example. How many ways are there to have answers to a 20-question true-false test? How many ways are there to have answers to a 20-question true-false test? Well, each question has how many ways? 2. And how many questions are there? 20. Now, so if we set this up with, I'm not going to put them all, but we'd have 20 spaces here, and they would each have a 2 in them, because there was a possibility of 2 for each of those. Okay, so we could write that as 2 to the 20th power, okay, which is 1,048,576. Okay, so I just want to point out that it's not always just typing in a combination or permutation. Sometimes you have to look at it like with how many spaces there would be to get a possibility for. Okay.